Okay, to find out the transfer function of the system using the Bode plot is first thing first, you need to see what is the flat value of this whole curve, and you can see over here this flat value, it occurs on positive 40 dB over here, and all other things, they are the slopes. So in this region you have a flat value, and once you have a flat value, so it is because of a constant term. So I can say that this 40 dB, it is equal to 20 log 10 of some constant k. So now, so 40 over 20, it is equal to log 10 of k. So k is equal to so basically log 10 of k, it is equal to 2. So if you can want to take the value, so you have to take 10 power 2. So you have to take the antilog of log 10 is 10 power 2. So your value of k is 100. So you have computed your value of k. And now you have to see these slopes as well. Now first slope is you are getting is positive to 20 dB per decade, and it will be keep on increasing. So at 1 you will have a pole with a minus 20 dB decay. So basically you will have a zero at origin over here. So it will be keep on increasing, but once a pole at omega is equal to 1 km over here, so it's increasing and flattened it up. So basically I can say that I have a 0 j omega at origin. After seeing this initial slope, I can say that I have a 0 j omega at origin, and then I have a pole 1 plus j omega over 1 at omega is equal to 1. Okay, and then you have a slope change again on omega is equal to 5. So basically, if you can observe that there are 3 corner frequencies, omega is equal to 1, 5 and 20. So the slope is changing on these 3 corners. So again at 5, the slope which was 0, it is again minus 20 dB. So there is another pole 1 plus j omega over 5 at omega is equal to 5, and again at 20 the slope is again added up minus 20 dB. So you have a pole 1 plus j omega over 20 at omega is equal to 20 over here. So after seeing all these things, so I can say that my h of omega, it will have a constant value 100 into j omega. I have a 0 at origin, then I have a 1 plus j omega over 1, a pole at omega is equal to 1 plus j omega over 5, pole at omega is equal to 5, and a pole at omega is equal to 20. Or if I can simplify it, so j omega into 10 to the raised power 4, if I can take the LCM, so it will be j omega plus 1, j omega plus 5 and j omega plus 20, or this is your h of omega. Or you can also say that if I can insert s is equal to j omega, so you will have 10 to the raised power 4 s over s plus 1, s plus 5 and s plus 20. and if you insert s is equal to j omega. So you can find out your function in any of the form, in h of j omega and in the hs form as well. So the main idea is that first thing first, you need to see where your curve is flattening out, see the dB value over there, and then from that value you can compute the value of your k, and then you can observe the slopes and the corner frequency where these slopes are changing. So I can observe that, okay, I have an increasing slope which is passing through 1 and it will keep on increasing. So basically I have a 0 at origin. So if you observe that your 0 is, you have a constant positive to 20 dB slope, and it will pass from omega is equal to 1, and then you have a dip at omega is equal to 5. So you have a pole over there at omega is equal to 5, and after that and before that you observe that your 0, it was keep on increasing, but there was a pole at omega is equal to 1 which flattened it out, and then you have a pole at omega is equal to 5 which added a minus to 20 dB slope, and then you have another pole at omega is equal to 20 which added another minus 20 dB slope, and sum up to be minus 40 dB slope. And I just observed that and write the equation. Thank you.